All right. So some context about Avonworth. We're a suburban school district. If you aren't aware of where Avonworth is, it's just north of the city, just off of 279, about 10 miles from the center downtown. Um, Typically, I teach about 24 students, so we went online, kept my whole roster, so I have about 24 students per class. And my school district is one-to-one with Chromebooks. This is our third year one-to-one. And students have access to the G Suite for education, all the different apps and things that come along with it. And the distance is, our distance program right now is asynchronous. We followed our FID instructional day template that we submitted to the state at the beginning of the school year, and we've relied on that. So the students are actually on a A-B day, and we've continued that. So I see the students are supposed to log in every other day to receive instruction from me. But it's all asynchronous, so we have it all posted and available for them to do. All right, so with the idea of using Google Slides, one of the big things that I found as a tool to get information to kids about projects is that it's pretty universal. The students know how to use the tools and features of Google Slides, and they're able to go through and manipulate the workspace and add things and change things as they need to. And it's also a great way for teachers to drop in. So if you're using Google Classroom, you can see their work as they're working on the different slides. And if they have a question, or if you're just going through the student's work itself, you can see who's on task, who needs help. And it's possible to provide them scaffolding right inside the Google Slide structure itself. I also use the Google Slides for scoring, so I have the rubric there, not just for me to help grade them, but also to help the students guide their project work. So I think we'll go and dive in here and look at one of the projects. So I teach genetics, and this is a project that we had just done recently, so I have lots of student work that I can show you. I would do this normally in school with little marshmallows, and we'd build these little characters. And a couple years ago, I did it digitally once when we first did one-to-one. And last year, we didn't do this project. So when we were going online, I figured that I could bring this back. And take some time here to load that. All right, so you should be able to see on your screens this is actually what the students would get. This sort of setup. So every one of these slides the students would actually get a copy of. It's really helpful through Google Classroom. You can make that setting so that students get a copy of everything, and everything's in one spot. The first page here is an index of all the links and things that students can quickly find. So if they start a project on day one of the project and they need to come back to it later, they can actually just click on the part here, because all these different links actually take you to different slides throughout. Nice thing about Google Slides compared to just a Google Doc is that you can embed videos. So instruction videos are embedded throughout. So as students have questions, they can watch the video and get some help as they go through the process. I went back to the old work that we did a couple years ago, and I actually took pictures and screen captures, and I made some GIFs of the different characters that the students had made, just to sort of give them ideas of what Martian is. So the project was to give the genetic makeup of these little aliens called Martians, marshmallow aliens. Just a little play on words. So the students we're learning up to this point, how do different patterns of inheritance work? And this is the culminating project. They had to go through and take a family of these Martians and show how they could end up having offspring. Some pretty detailed things. In class, I would go through and talk about how do you do a multiple allele Punnett square, and on the video that I provide them, I show them how to go through and use a calculator online to do some of the work. So using the Google Slides here, it sort of manages the project for them to figure out actual outcomes, like what is an actual Martian baby going to have. We had to create some method of modeling chromosomes being produced through meiosis, and it's a 1.5 chance of getting one allele over another. So I use a little cardstock and I show them on a video that I created. And the students, we would do this normally in school. The students never had that exposure because just when we closed down. So I had to go through and I showed them using the document camera, how do you create these chromosomes? How do you model, inheritance through this type of outcome? And the students have workspace that they can go through and basically, nice thing about using Google Slides, the students can open up and they can actually type right in the boxes. And what I had done was for them, at the top here it says with these links, they can actually get directions to that page again, because it would have been on a previous slide, or they can actually see an example. And there's examples on here. So there's that page already filled out with different genetics. So that gives them an idea of what it would look like if they were going through and working on it. They can actually see what does an actual correct response look like. Um, the genotypes I gave them were actually a lot easier for them to complete. So they did different crosses, and of course they're going to make a family tree. So I give them a visual of what a outcome would look like with the family tree, and I gave them clip art, some clip art that they can use, and they can also get their own. And part of this also is we have a rubric that we can use to score them. So it was already planned out. I used this rubric before, modified it a little bit for the digital setting at a distance. So with that, we can look at some of the student work. So, doing a project online, here's some student work of those pages I showed you with them figuring out, uh, what are the possible genotypes and outcomes, and using a Punnett square generator. So all they had to do was go through and read. I gave them the genotypes already, and I did this in, I had probably about 6 variations of the genotypes, and I had the students, so they all had different families. So when I looked at the student work later on, I could say, well, I could see this family pattern, and I could say, oh, that is possible. Those are the possible offspring. Or I could say, oh, nope, missed that. Maybe this genotype or that genotype won't work. But they get a pretty simple readout on what the probabilities are on the Punnett square generator, and then they have to actually do the actual outcomes, and that's what you see on the right side of the screen here. The kids name them, all the different kids, and they try and figure out what are all the possible phenotypes and genotypes, and those are listed. So that's some possible student work. You've probably seen the little Martian guys all throughout. I took them and put them throughout the slides to sort of decorate them. But here's a GIF I created of one of the pedigrees. For this one, the students, they got different characteristics that went on the web, and they actually went out and got their own accordions. It's one of the traits is accordion arms, so they just some wacky things because they are Martians. Legs, they went out and got those. So going out and finding clip art is pretty interesting. Shows some creativity. I mean, at a distance, some of this stuff can be kind of difficult to give them some ownership of it. But you can see some variations that they came up with, right? Because it was open to them to figure out how they wanted to make the accordion arms or what kind of legs they wanted to use. So you can see some variation here. So some of them are pretty funny. This student here, this is one of the most unique ones. She actually took the marshmallows, but she drew. She's a great artist, and she went through and she actually drew each of the parts and then colored them in, and then so she made her own little clip art herself and actually worked on creating the Martians. But that was really great. And you get to really see some of the family patterns, and we cut like color patterns. If you have a yellow allele and a blue allele get together, then make green, so you can see that sort of flowing through the family. There we go. So for setting it up on Google Classroom, it's really nice is that all the stuff's going to happen in one file, so the students have all one location to work with. So when I was setting it up, really there was only one file that I gave them, and I made a copy for all the kids. So you can sort of see so this is one variation of it, and then I put a little number here. This is number 1. This is the first variation, and then I had 4 students that got that one for that class. So I had so many different variations. That way that, if they were talking to each other, well, I've got, orange. Like, well, I didn't get orange. So then they realize that they have different genotypes. And then I'm giving them some variability in what can be turned in. When each student gets a copy of it, then it automatically puts the name on there for them. And when they're working on it, I can go through those files and see who's on. I can check out the work, or if they email me or text me through Remind, I can give them some feedback on their progress. All right, so now that I've finished this, this was due about maybe 3 weeks ago now, and just think about the availability of what we can do with Google Slides. It's so much more than just a presentation. I've included on here some virtual lab activities that I've done with them. Also case studies. That's what we're doing this week, is a case study with the Google Slides, and I created it. I used to use a worksheet for the case study. Now, being at a distance, the students can complete the case study, and they have everything at their fingertips. There's simulations and videos. You'll see it. It's an antimicrobial um, uh, case study. Then you can go through that, and everything's in one place. The students don't have to go and find another document on Google Classroom to figure out how to do this lab. It's all in place. That's nice. WebQuest could be really well done on this sort of method, because rather than having students just going out there and searching the web, you can have all those resources put together in Google Slides. So whether it's a link or a video, you could have one place for them to do their work, and you could also have places for them to put information, or as they're finding the information, typing it out and adding it to the Google Slides as sort of what they would turn in. Um, Another thing I'm thinking about as we continue, and next year's sort of uncertain, we need to start thinking about how do we manage group work and division of responsibility. And by leveraging Google Slides, and you might be able to split groups up, and this could be their hub where they can put down different ideas and put things together. So they have a place to store materials on one shared Google Slides, and the teacher would have it too, so they can go through it and look through and see what the group's working on. So those are some of the different ways I'm thinking about trying to use this sort of setup. So some helpful tips. What's really nice about Google Slides, just like if you were using PowerPoint, you can go through and you can link text or even pictures by highlighting and then linking it either inside that set of slides, which actually can create a website too that way. But that's really helpful, that you can link back into the video, and having videos that you can actually select, whether it's from YouTube or from a Google Drive, having those there so the kids don't have to actually leave the document. They can see it right there. It's an advantage over Google Docs. Google Docs cannot have linked images, and they cannot have videos that are embedded. So with Google Slides, you can do that. And even images. So here's an image of my little explanation for the slides for the presentation, and it's a link. So you can have images that are actual links. So here's my website. If you click on it, that image actually takes you to my website. So it's nice to have that as a link as well. So students can, so if you have like a preview page for a website, the kids can see that preview, click on it, and then take a look at it. And that's all through that link system. Another thing, another suggestion I would give is having places for students to record information. This is next week's lab, and you can actually see how it's set up. This will be all Google Slides, and here would be a checkbox for the students to make a selection, and here is a written response. So the students would actually type their responses in there. This is a evolution case study, the mosquitoes of the London Underground system. So how they became different species, and it has them go through various videos and some documents and things that are all embedded right in the Google Slides, and you have those. Okay. So we have those, and you can look at those. And all right. Oops. So thoughts for me for my next steps. Like I said before, trying to think about how to get group tasks together using Google Slides. When think about how do we increase the creativity in which the students do. So it's not just me giving them a bunch of tasks to do, but I want them to actually start thinking about what kind of digital artifacts can they create, and a Google Slides might be a great place to do that. Whether it is just putting images together to make a collage or something like that, it gives you a workspace, a place where the students can do that work and then just post it. And it's easy access for the teacher to get to. It's easy access for the students to ask for help, and the teacher can drop in and help with information. If it's something pretty technical, you can have pre-made scaffolding for students, so that you can actually have pre-made slides that get inserted into the presentation, where the students get additional help, maybe hints and clues if it's like I don't know, maybe some type of scavenger hunt or something like that. But those are some of the things I'm thinking about and improvements that I'm thinking about. So I think might be helpful right now is just real quickly, I have a set of slides and things that you'll get access to. Everything I've created with Google Slides and sort of managing projects. So everything for Meet the Martians is in the folder here for Meet the Martians. And you'll have access to all this. It's open up to everybody. The lab for this week, the microbial resistance, that is available for everybody. Next week's lab that I have already made up, mosquitoes of London, all that, that's a case study too. You have access to that. And solving Punnett squares. How do you fill out a Punnett square at a distance? I use Google Slides, and those I have 2 sets of those, and those are available too if you want those as well. So that's a real quick rundown. If there's any questions I can answer, we can
Wow,
work on
Doug,
those.
you have a ton of great ideas in there. Um, I know Rochelle wanted to know if you'll be sharing the project, which I think you just answered.
Yep.
Do you want to share anything? And maybe this is only my curiosity, but as far as making that clip art for the students, how involved was that for you?
The clip art was really easy. I went through and searched for just a Google search on images, and I would look up animated wings clip art, and I would find it. And I was trying to find ones that had a clear background. If you'll notice, whenever I was going through the slides, there's a white background for all the little Martians because some of the clip art doesn't have a background. If they picked something that had a white background, I just put a white background on it so you didn't see the intersection of the different pieces of clip art. The kids are really great at finding it. Some of them found some really fun arms and legs, and they really just went and above and beyond. And some their own. Some of them use all their own clip art. They went out and searched for their own stuff. But yeah, it's really simple. You can just do a quick Google search for hand-drawn wings animated, and they'll pop up with a variety of them.
So there's one question also. How long did the students have to do this activity? Weeks, days?
Yeah, they for the Martians activity, they had a week, essentially a week of class time, a virtual class time. I get basically about 60 minutes twice a week. So it was about 120 minutes. And I would, as students were turning them in, I would, ask them some questions through Google Classroom. Hey, this is great. How much time did it take you? And they're telling me it took them about an hour, maybe an hour and a half. Some students got stuck in places and they said it took them about 2.5 hours, or especially if they're waiting for me to give them some feedback, like if they got stuck on one of the processes. Because it's really detailed. One of the things about going online, so much they had to read to understand. I would, and helping them out, they would, take a break and then have to come back or wait for me to answer them. But yeah, I would say probably I gave them a whole week's time to work on it.
That's wonderful. Other folks who are in the session, you're welcome to open your microphone and ask a question. If you'd rather do that than typing it in. And I forget, Doug, did you say how many students you have?
Yeah, I have overall through all my classes. For Bio 9 is what I use the Martians activity for, and there's 85 in Bio 9.
Okay, so a good number of students. And have they given you feedback on how they like this activity online versus, of course, they didn't do it face to face, but
Yeah, I don't know. I got some feedback. I think they seem to be liking. They definitely like this a lot more than just watching a video and answering questions. That's kind of what I got back from them. Some of them said that it took a long time, but they had a whole week, so it was the only work they had for biology that week was to do that. So I gave them time, and I said, contact me. I'll be here to help you out. And many of them didn't even ask for assistance. They seemed to just pick it up and run with it. I think having the videos and to show them like directly how to use it. Of course, they had different information, so they were just using it as a template and then applying it.
So, Doug, if I could ask another question too.
Sure.
We're finishing up with pedigrees here. It took us almost 3 weeks just to do our AB schedule like you guys do. And this is how you guys taught all the genetic stuff through this project.
Yes. This project, we did some Punnett squares and some patterns. We talked about, because in the project itself, it does sex linked, and we do complete and incomplete dominance. So we did some background work with that. Like there was I had a web quest about different kinds of patterns for inheritance. So starting off with Mendel and the basics, and looking at that and then branching off on that. So prior to that, prior to the project as being our culminating activity, we probably spent 4 weeks. I'd say about
Okay.
4 weeks on
That
genetics
makes more
prior to
sense then.
this.
Okay.
Yeah, there was a lot of build up to this, and the idea with the project was rather than because at a distance it's hard to give them a test or because we're looking at a skill here too. It's really hard to just give them a bunch of multiple choice questions and expect them to give you authentic answers. Here, that if they can go through and do this, and they're showing, oh, you really get the patterns. And you can even pair this with a written response to really have them express what they got out of. If we were in class and we did this with real marshmallows, I would have them do some type of writing task with it as well.
Thank you.